fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So, as you probably could see from the title of this podcast episode, this one's probably going to be a pretty spicy one, so I hope you got your milk and ice cream ready to cure the heat. But this episode, we're really going to get down into some weeds here on some technology concepts, specifically those that have been dominating the news cycle, I guess you could say, in the past few months, that specifically being AI. So we're going to be diving into AI, and as the title of this episode suggests, it's actually a lot easier to create your own AI than it kind of seems to be, if you take it at face value for how people are describing AI in the public sphere. So we're going to get into that. But first, let's get into this week's trivia question. So this week's trivia question is, when was hyperthreading first introduced? So when was hyperthreading first introduced? That is a trivia question for this week. Now, before we get into the cybersecurity tip, if you'll indulge me for just 1 second, I just have something to say that I want to say really quick, and that is, what the heck, Microsoft? No, this isn't about your new Bing shenanigans with whatever the heck that naming scheme is, but this is specifically about your app called Microsoft Teams. It's kind of getting on my nerves at this point. So I don't know how many of you out there in the real world use Microsoft Teams for work, but I can't tell you how many times I've gotten into this feedback loop with Teams where it doesn't notify me of any new messages because I don't have it as an active window. It's not like my main window. And I never make it my main window because I never get any messages, or at least any notification of messages. So because I don't get any notification for messages, I have no reason to bring it to the main window. And because I don't bring it to the main window, I don't get notification for my messages. So it just feedback loops on itself until a few hours go by, and I think to myself, I haven't gotten any notifications from Teams. Maybe I should check that. And then I check Teams, and then I see, all of a sudden, all these notifications pop up for messages that have come in from either chats or the teams that I'm a part of. And I'm like, what the heck, Microsoft? And it's not and the thing that, you would think that it would, want me to be notified because it wants me to use its app more. But I don't know. Now, the thing that kind of annoys me about this is because, it'll happen where I'll go sometimes hours without responding to someone's Teams message. And it'll make me feel like, for family-friendly programming purposes, a bad person for ignoring them. When in reality, I didn't ignore them intentionally. Teams just neglected to notify me that someone messaged me. So is it my fault? Is it Teams' fault? Kind of hard to say. I mean, sure, I could have checked Teams a little more often, but when I'm actively working on stuff, if I don't get a notification telling me to go check Teams, I'm not going to bother checking Teams because I just assume that I don't have any notifications. But obviously, I can't make that assumption anymore because Teams has proven to me time and time again that that is not necessarily the case. Now, I guess I'll preface this by saying I potentially could just be a complete idiot and I'm missing something in my settings that I literally just have to tick something and then this problem goes away. But based on the looking into this problem that I've done, some of the researching I've done online, I've come across many forum posts on the various Microsoft forums about it, which, a little bit of a side tangent here. Those, in my opinion, are their own special kind of awful, because I'm not sure about you guys, but whenever I find myself on either a Microsoft forum or their documentation trying to solve either a programming problem or a Windows issue, I can almost never find what I'm looking for. I don't know what it is, but they are just not helpful. But there's one in particular that I found where it was literally just pages and pages and pages of people commenting literally the same issue and being like, yeah, I have this issue too. Yeah, I tried this and this, but that doesn't fix the issue. And then you have like the generic Microsoft quote unquote solution. And then you have all these people responding like, yeah, I tried that and it didn't work. I'm still having the problem. So yeah, Microsoft, I think you need to fix your app. Which the funny thing is before I used Teams, I used to use Slack for work when I was at a different job. And I gotta say, I never had this issue with Slack. Now, granted, I haven't used Slack in a while, and as far as I know, Teams has some more features than Slack does. But at the end of the day, it should still... They still have the ability for you to chat amongst people within your organization and like notify you when either any channel or team you're mentioned is mentioned, or if you specifically are mentioned. And for whatever reason, Teams just likes to say that I am currently away or something like that, or be right back or whatever the heck it is. Just out of nowhere, if I don't have it as the active window and I'm actively having it in the foreground and like moving my mouse on it to make sure that it's still quote unquote active, which to me is kind of dumb. But you know, I don't really have anything else to say. I just thought, I'm assuming, based on the Microsoft forum posts, it won't surprise me if there's at least a few of you out there that have similar issues to me. But with that out of the way, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, this is going to be a little more software development oriented rather than just broad security tips. And the reason for that is one way that, a very common way, almost not, I guess maybe not every way, but I would say the majority of ways that programs get exploited is due to user input. So whenever you're dealing with user input in your programs, always assume that the user input is garbage or malicious and handle it accordingly. Never trust your user input. The only time where you can kind of assume the input is valid is when you're initially testing the program, because going through the laundry list to make sure your input is valid and correct just to test one feature that you're working on can kind of be a pretty tedious task, especially if you're, trying to make sure that the input is valid and everything is correct when literally all you're trying to do is add two numbers together. That's a little over the line, at least when you're testing. Now, obviously, once you want to make this a final product, you better be parsing your input, because worst case, your program crashes and you don't want your program to crash. That's best case. Worst case is there's like a Stack Overflow, or not a Stack Overflow, a buffer overflow, or some other kind of overflow, or SQL injection, or something that happens because you didn't bother to make sure that the input that the user gave you was actually valid input. Now, like I mentioned, some of the most common forms of this is buffer overflows and SQL injections. So SQL injections, generally more web-based, but not always. Now, basically how the SQL injection works is you don't parse the input and you just send the user's input directly to an SQL database. So basically all the attacker has to do is write a malicious SQL statement, or basically just dump the table, like drop the table, and boom, poof, all your data's gone because you didn't feel like parsing their input. And then the other infamous one is the buffer overflow, which is where the attacker puts more data as their input than you have a buffer to handle. Now, generally, this is only really a problem with languages like C and C++, or other like low-level languages where you have to like specifically set the length of your buffers to like read in stuff, or you're not dynamically allocating space and memory to accommodate for larger inputs. More I guess higher level languages like Java and Python generally handle all that for you, so you don't have to worry about it. But if you're dealing with low level stuff, this is let's just say it's a more common problem than it should be. We'll just leave it at that. So basically, the premise of the buffer overflow is you overwrite the buffer, and then because you're overwriting the buffer, you go into the rest of memory, overwriting other parts of memory, and then if you can figure out where the return address is in memory, what you can do is you can put your own address there, and then you can do what's called a no-op slide, which basically is just a no-op is just essentially a skip instruction that tells the computer to go to the next one. So basically what you can do is you can add this address where the return address is going to be. You can put your own address there, and then you can either specifically jump it to like get a shell for yourself, or what you could do is make a giant no-op slide and then put the return address somewhere in that slide. So you jump to somewhere in the no-op slide, and then you just go no-op, 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 and just keep skipping through all those instructions until you get to the end of it, which is where the malicious code is, which generally pops the shell. Which essentially just means it gives the attacker a shell on the system. This is obviously dangerous because they have an active shell on your machine that they can input whatever commands they wanted to, just like they were right at your computer. And this is especially bad if you are an administrator or this is run on the root account, because then they can literally do whatever they want with no need for any password, and any command they do just gets executed. So yeah, make sure, software developers out there, that you are always parsing your input and making sure that you're protecting yourself from attacks like buffer overflows, SQL injections, and all that good stuff that comes from dealing with user input. So that is your cybersecurity tip for the week. Now, before we get into the nerdy things, I just wanted to touch on a couple news stories that I found kind of interesting. The first of which being, if you thought that you didn't already have enough subscriptions, well, boy, do I have news for you. The old Zuck, our boy the Zuck, just launched or unveiled or whatever, I don't know. He came out with a new subscription. So if you didn't hear, Facebook, Meta announced that they're now going to be offering a subscription. Yay! So basically it's essentially, which is kind of funny since they're literally just copying exactly what Elon did over at Twitter, where you can now pay Meta money each month, and you can get the coveted blue check mark next to your name. And then there's some other things too, like supposedly like identity and privacy protection, and I don't know. But I do recall that essentially have to provide Meta with a government ID in order for this to happen, which I don't know about you guys, but there ain't no way in heck I'm giving the Zuck my government ID, whether that's a driver's license, passport, or any other form of ID. That ain't happening. So the subscription starts at $11.99 a month if you go through their website, or $14.99 a month if you go through iOS. Now, some of you might be wondering why it's more expensive on iOS versus just on their website. Now, as cool as it would be to have the conspiracy that it's because Apple, shut down privacy tracking for third-party apps, so Meta is not getting their money through tracking you all over your phone. As cool as that would be if that were true, I'm pretty sure the more likely answer is the fact that Apple charges they basically take a cut of any in-app purchase or purchase on the App Store from everyone. They take a cut. Now, I forget exactly how it's structured, but essentially, if you're like a small developer, if it's just you and you don't really make much money from the App Store, I think they only take like 15%. But then like the bigger companies that make lots of money off the App Store, I think the threshold was like $1 million or something like that. Anyway, then they get charged. I believe Apple takes like a 30% cut or something like that. So this strategy, I think Netflix even mentioned doing a similar thing to this, but where they have like two different prices, one on iOS versus one on like their main website. And basically the main reason for that is to account for Apple's cut that they take. So I mean, it's not a surprise that Meta is doing the same thing here. It's fairly a common practice. And I mean, it's not surprising, right? Corporations passing on expenses that they accrue onto the consumer, so you have to pay them. How nice of them. So yeah, basically my bet, I would happily put money on the fact that the reason why it's more expensive on iOS is to account for the cut that Apple takes, so they can still make essentially the same amount of money. So I guess the good news in all of this is any of you out there with Stockholm Syndrome and you wanted to give more to the almighty Zuck than just all your personal data, you can now pay tithings to him to show your devotion in the form of this subscription. So that will probably be very welcome news to any of the Zuck fanboys out there. Now, in other news, this I think has actually been around for maybe a little while, maybe a couple weeks or so. But Apple, if you didn't hear, Apple had a class action lawsuit filed against them for their butterfly keyboards. Now, the butterfly keyboard, for those of you who might not be aware, was on 2015 to 27 MacBooks and 2016 to 2019 MacBook Pros. So, it from the inception of the butterfly keyboard, it was always in the headlines for controversy. Not many, it didn't exactly have the best, I guess, public perception. I think I saw a poll, I believe it was from 9 to 5 Mac. They did a poll back in, it was either 2018 or 2019, one of the two. And they basically did a poll like asking people what they thought of the butterfly keyboard, and I think it was around like 40% or so actually said they liked it, and everyone else was either some form of dislike, and then I think there was like some other small percent, like 5, 6, 7%, something like that, where they just had no opinion on it. So yeah, it didn't exactly have the best track record, and it also failed a decent amount. It failed enough to the point that Apple had to make a repair program. And basically the point of this repair program was if you bought a MacBook or a MacBook Pro that had a butterfly keyboard, if the keyboard failed on you or you had any issues with your keyboard, within the first 4 years of its life, they would replace it for free. They basically give you a brand new top case, or if you had just a single bad keycap, and I think initially they would replace the keycap for you, but eventually they just switched over to replacing the entire top case. Now, the reason why I say 4 years of its life rather than your ownership is because if you happen to buy a used MacBook Pro today, say it was from 2017, and then 2 months from now your keyboard goes bad, they're not going to replace that for you since it's older than 4 years. Now, if you bought the same used MacBook Pro from 2017, say in 2020, that was still within the 4 years. So if you had a keyboard failure within that year, they would have replaced that keyboard for you. So if you were in a situation where you had a butterfly keyboard fail on you, assuming you still have the receipt, you can actually, if whoever was doing the lawsuit hasn't reached out to you, you can file a claim. Just make sure you have your receipt with you, and you can actually get some money for your troubles. I believe it ranges anywhere from $50 to $395. They have like 3 different tiers. The lowest tier is the $50 tier. Essentially, you just had a keycap get replaced. Then if you got a keyboard replacement, that's another tier. And then the max $395 tier is if you had like 2 or more keyboards get replaced on a single device. So anyone out there that had a keyboard go out on them and had to get it replaced by Apple or an authorized Apple service repair place, you could get some cash out of this. And then again, based on the polls from 9 to 5 Mac, and Mac Rumors, it seemed like about 20% of users voted saying that they had issues with the butterfly keyboard and had to get them replaced. So it was, with how many MacBooks they sold, that's obviously 20% is obviously a decent chunk. So it wasn't like, a very small number. But again, with only it being 20%, the vast majority probably didn't have any issue. But again, with how many of these machines were sold, 20% is a good chunk of them. So I mentioned at the very beginning of this episode some hot takes. So here is the first hot take of this episode, and that is that I kind of like the butterfly keyboard. I'm not going to lie, which I know I'm probably going to get some flack for that, might even get canceled, but at least in the tech world anyway. But quite honestly, I don't care because I enjoy typing on it. I don't know what else I really have to say. I mean, I like the clickiness of it. Like, I like the sound it makes when I click clack on it. I mean, I'm a code monkey. I click clack on keyboards all day. So I like that. Now, I understand the fact that, there isn't much travel, and the keyboard fails all the time, and all the talking points that everyone that hates on the keyboard likes to say. But I don't know. I mean, I don't have an issue with it. I haven't had a problem with mine failing. Obviously. So I don't know. I just like it. Now, I'm definitely in the minority because, as I mentioned from that 9 to 5 Mac poll, only about like 40% of people who voted in that poll actually said they liked it. So obviously the majority of people don't like it. But for what it's worth, like, I really don't, I'm not like a keyboard enthusiast or anything like that, but from my personal experience, there really aren't many keyboards that I don't like. The only, I guess, keyboards that really stick out to me that I don't like are those flaming hot pile of garbage e-waste keyboards that you'll get when you like buy a new computer or like a used computer, and they bundle in a cheap keyboard in with it. Like those things are terrible. Those are horrible. But out of all the keyboards, aside from those keyboards, I've used the Bluetooth Magic keyboards that Apple has. Those are pretty good. I've used the keyboards before they went to the butterfly keyboard. The butterfly keyboard. I haven't used the new Magic keyboards that are on the new MacBook since I haven't had a chance to play with any of those. My Dell laptop's keyboard is pretty decent, a little mushy, but at least on like it's not that like the key pressing isn't bad. It's just like if you like press on around the keys, it's I have a Razer laptop. That keyboard's great. I have a couple mechanical keyboards, both with blue switches and brown switches. Both of those are pretty good. I haven't tried any linear switches, so I can't say anything about those. And then obviously my Model M keyboard that I have is pretty top notch as well. And I enjoy typing on all of them. Like if I had to pick a favorite, that's tough, because one thing I do like about the blue mechanical switch is how loud and clicky they are. The only problem with those is they're not really socially acceptable, I guess you could say. Like, it's definitely not the keyboard that you can, like, take into your office with you at work and just go ham, because obviously you're not going to have a problem. But if you don't have an office to yourself and you, say, are in a cube farm or you share an office with other people, you might start to annoy some people. So that's one issue with the blue switches, although I do like them. So I guess if I had to pick a favorite one, that's probably tough, but I think I've probably used the Magic keyboard the most, so that would probably be up there, or just like a mechanical brown switch, because the mechanical brown switches are basically like the blues in the fact that they're clicky and tactile like, but they're not quite as loud, so they're a little more tolerable for the average person. So you can you don't have to necessarily worry about getting death stares when you're typing on your keyboard around other people. So now that I've managed to tick off everyone, both in the tech community and the keyboard enthusiasts out there, let's get into what nerdy stuff have I been up to this week. So if you listened to last week's episode, you know that I finished 2 projects. Now, the naive among you, or the new listeners to the podcast, might think, wow, you just finished 2 projects. How do you have anything to talk about in this segment? And if that happens to be you, I would kindly ask you to go listen to more episodes of the Dark Assassins podcast, because those that have listened to the podcast for a while know that just because I finished 2 projects does not mean that I now have nothing to do. Quite the contrary, actually. I was coding up a storm again this week. So I came up with a new strategy for my iOS development when it comes to making apps. So rather than making an app that I'll realistically probably never use because it's too much of a hassle to have to reinstall it on my phone every week, what I've decided to do is essentially create modules or microservices or Lego blocks, if you will, when it comes to apps, and basically just make a quote-unquote app that has one specific functionality. So for instance, this week, I created an app that literally all it does is unlocks with Face ID or Touch ID, and that's it. Literally all it does. So when you first open the app, it'll prompt you if it can use Face ID or Touch ID, and then assuming you said yes, it'll unlock with Face ID or Touch ID. Otherwise, it'll just default to whatever your system's passcode is, and then it'll unlock. And then there is a button on the screen, on the unlocked screen, that you can lock it. and then there is and then once you lock it, on the locked section of the app, it says unlock with Face ID, or if you're on a Touch ID device, it'll say unlock with Touch ID, and then you click that and you unlock it again, and that's literally all it does. But the reason why I wanted to do this was because if I ever want to make an app, say that uses Face ID, literally all I have to do is take the Face ID component from this demo app and copy it over to the app I want to make, and I now have Face ID. So basically the point of this is to essentially build Lego blocks on top of each other, where I can just grab a component from this example, grab a component from that example, and then build it up into a better, more practical application rather than just a demo. Now, this is one really fantastic thing about software development, because once you make one project, you basically, as you create more projects and as you implement other things, whether you're reading in file input, whether you're handling user data, whether you're doing networking calls, REST APIs, whatever you're doing, when you create those projects, you basically create a library for yourself. Not in the sense that, like, I can call this library and it'll do stuff for me, but in the sense that you can go back to these old projects, look at how you did something, and either copy that code directly or take inspiration from that code and modify it to whatever new purpose you need it for to solve whatever problem you need. So this is basically at the core, that principle, just like down to the core principle of it. So rather than creating a personal project of something actually functional, this is essentially literally just the building block portion of it, without any of the added fluff and features that an actual app or program would have. So that's basically kind of my approach that I'm going forward now with some of my iOS development. And I took the networking code from the Universal Countdown app I made, and essentially I guess I didn't really strip it down even more, but I generalized it even more than I already had generalized it, and added a feature to demonstrate the fact that it can send as well as receive. And I added another feature to it which allows you to actually stop and start a connection without having to kill the whole app. So that's nice. So yeah, I think that was basically the nerdy things I did this week. But I wanted this specifically to be a lesson to all the developers out there that once your project is done, that doesn't mean never look at it again, because it can definitely be a valuable tool to reference if you did something specific in there, like maybe you're doing a lot of networking programming, and then you have another project down the line where you want to do some networking in it. You can go back to that other project and reference it or take things from it, and makes your life a lot easier once you've already done it once, and build up this library of resources that you can go back to. So now let's get into the second hot take that I got this week, which is the fact that anyone can make an AI and you aren't special if you made an AI. Now, why do I say this? So if I came up to you and I told you that I programmed my own artificial intelligence, or AI, what would you think? Now, I would assume that if you haven't done any kind of studying or researching into the field of AI, most likely what probably comes to your mind is you would think that I made something akin to ChatGPT, New Bing, Bard, Stable Diffusion, or DALL-E 2. Now, by the way, Bard is the thing that Google's calling their New Bing competitor, which, can we please, Microsoft and Google, please work on your naming schemes? I mean, these are horrible names. Now, one thing I will say is I have heard rumors that Microsoft's AI is actually called Sydney, although my kind of understanding of that is that that was just the internal code name that they had for it. But personally, if you ask me, I think Sydney's definitely a better name than Bing Chat or New Bing or whatever the heck they're calling it. But yeah, anyway, back when the dinosaurs roamed the earth, aka when I was in high school, just kidding, I'm not actually that old, but I wrote a program to play rock, paper, scissors. And this was in my, I think it was my AP computer science class. And the extra credit for that program, was make the program smart so it always wins. But the caveat was you can't make it obvious that it will always win. So you basically had to make it look like you still had a chance, but you'd end up always losing. So in a way, this is its own version of AI because you're programming intelligence to it in order for it to, win. Now, granted, at least my solution was cheating. So basically, it would play normally, just pick a random rock, paper, or scissors, and then it was a best 2 out of 3. So whenever you, the user, would have one win, what it would do is it would play normally, and then if it saw that you would win, it would change its move to be a tie. And then if it actually won, then it would just win. Or if it regularly tied, it would just regularly tie. But in a way, that was kind of a form of AI in a sense, because if we actually look at the definition of what AI is a very broad term, which means, quote, the ability of a computer or other machine to perform those activities that are normally thought to require intelligence. So obviously that is a very broad term. So literally any program that you write that has any form of intelligence or can perform any task that would be thought to usually require human intelligence is technically artificial intelligence. So literally what this means is if you know how to play any kind of game, you can program an artificial intelligence. Me personally, I've programmed, in addition to the rock, paper, scissors AI, which it's kind of funny to even call that an artificial intelligence. But I also wrote one to play chess. I've written a couple different AIs to do Pokemon battles. I've written AIs to play the game where you that game where you say, I'm thinking of a number between X and Y, and you have to guess what the number is. Written an AI to guess that. So none of these are anywhere near as complex as, the stuff that OpenAI and Microsoft and Google are pumping out. But nonetheless, it's still AI. So literally, if you know how to play any kind of game, rock, paper, scissors, tic-tac-toe, chess, checkers, anything like that, you could program an AI to play that game literally with just the knowledge you have, and then put your knowledge to code, and boom, you have AI. Now, obviously, you're going to need a little bit of programming experience, but for something basic like tic-tac-toe or rock, paper, scissors, you really don't need that much programming experience to be able to do that, because there's not a ton of logic and checks involved that you need to do. So yeah, literally any video game or card game or anything, you can make an AI for it. So I think first what we have to kind of think of is, because if you can literally hard code a computer and that becomes an AI, how is it that a hard coded computer to play, some game like tic-tac-toe is an AI, while also something as advanced as like ChatGPT, Lambda, DALL-E 2, all of these are also AI. So, as I mentioned, AI is a very broad, encompassing field, if you will. So, think of AI like the term car. Car is a very big, broad field, right? It's a big, broad thing because you can have a car that's a sedan, you can have a sports car, you can have an SUV, you can have a truck. All of these are considered cars, yet they're distinct and different from one another, right? While they're all cars, they all have their own differences. So AI is essentially the highest level, all-encompassing, since, as we mentioned, AI is the ability for a computer or other machine to perform activities that are normally thought to require intelligence. So that is AI, that's the highest level. And when we're talking about AI, there's really 3 levels to artificial intelligence. You have the top level, which we mentioned, which is artificial intelligence. And then you have the level below that, which is machine learning, which I'm sure you've probably heard the term machine learning before. Machine learning is the second level, which is a subsection of AI. And machine learning focuses on using data and algorithms to imitate the way that humans learn and gradually improving its accuracy over time as it gets introduced to new data and all that stuff. So generally, machine learning is done through the use of neural networks. So rather than the higher level artificial intelligence, like those basic hard coding of logic and algorithms into the code, machine learning uses neural networks, which we'll get into a little bit of what neural networks are. I don't want to go super in depth. One, because personally I don't think I'm super qualified to talk about it. But 2, it would probably go over a lot of people's heads because it's essentially its own specialty field. Like, you can literally go to school and do nothing but machine learning and get a degree like specifically in machine learning. Like, it's its own thing. Like, it's a big thing, and I mean, in fairness, it does pay pretty well if you know how to do machine learning. But we're getting a little sidetracked here. So the third and deepest level of artificial intelligence is known as deep learning. And similar to machine learning, deep learning is as well a subsect of artificial intelligence as a whole, but deep learning is also a subsection of machine learning. So if you think of this as like a Venn diagram, you have a really big circle, which is artificial intelligence, and then inside that big circle, you have a smaller circle, which is deep learning, or machine learning rather, and then inside the machine learning circle, you have a slightly smaller circle, which is deep learning. So they're essentially the thing above them, but more specialized. So all of them are various forms of machine learning, but they're essentially different in their own right. So basically, the main distinction between deep learning and machine learning is, we talked about machine learning uses neural networks. Deep learning also uses neural networks, but it's considered deep learning if the neural network has 3 or more layers to it. Now, we'll get into what the layers mean in a little bit here. But when you hear about the AI tools now, like the ChatGPTs and the DALL-Es and the Stable Diffusions of the world, those are definitely deep learning models. They're using deep learning. They're definitely a lot deeper than just your broad, overarching artificial intelligence or even machine learning. So I've mentioned neural networks. So how exactly do neural networks work? Well, that's, as I kind of mentioned, that's its own whole can of worms. But there's different types of neural networks out there. Just to name a few of them, there's multi-layered perceptrons, convolutional neural networks, or CNNs, recurrent neural networks, and long short-term memory, or LSTM. So those are just a few. There's obviously a lot more than that. But just to kind of give you a sense that there's a lot of them. And each one kind of has their own, I guess you could say, its own use case as for what you would want to use it for. It has its own thing that it's good at. But what it all boils down to is each of them essentially boil down to this one structure. So you have an input layer, which essentially accepts input data that you feed it, and then you have processing layers, which are generally called hidden layers, or in the case of convolutional neural networks, convolution layers, and then you'll have something like an output layer, which will actually output the data that you want. And basically the point of the middle layers is to filter the data to, essentially that's where you could think of them as like the neurons that fire. That's why it's called a neural network. So basically, if I have, say the value that gets to this neuron is a 10, based on that value, it'll fire off to some other node in the neural network, and it bounces around. And basically the point is to identify, characteristics of whatever it's trying to learn, and then output, a percent certainty that it is or isn't a thing. So we'll get into an example about that. But essentially the TLDR, or I guess since this is a podcast, the TLDL of neural networks is basically how they work. Is they take in input data, then do some fancy calculus and matrix math and other kinds of math on the information that's passed through the various layers. It does various kinds of math at each one of those layers, and then spits out a probability of how certain it is that is the thing. So if we take an example of an image of a person, if the model was trained to identify people, basically what happens is you feed the image of a person into the input layers, and then it does all of its fancy math, and then it outputs a probability that there is a person in the image. So it could be 90%, it's 90% sure that there's a person in the image, or it could be like 2%, like it's 2% sure that there's a person in the image, or in other words, it's pretty sure that there isn't a person in the image. So the way that it quote unquote learns is by tweaking the weight modifiers in each one of these math equations. So how the machine learns initially is you have to feed what's called training data to it. So the point of the training data is you feed it a bunch of data for the thing that you're trying to train it on. So if we go back to trying to identify a person example, you feed it a bunch of images of people, and I think you can also feed it not people, but basically you label everything to basically tell the model, the neural network here, this is a person. So then based on that, because it knows it's the person, it'll try to identify, various characteristics and then adjust its weights. And then once all the training's done, theoretically, its weight should be adjusted to be able to take an image and identify characteristics of a person, and then be able to, with a high level of accuracy, be able to tell you if there's a person in that image or not. Theoretically, of course, because it doesn't always work that cleanly. But so this is essentially, and if you think about it, that's essentially how ChatGPT works as well, except rather than taking images as data, it just takes a bunch of words as data. So literally, all ChatGPT is doing is taking your prompt as input and then running it through all these fancy math calculations and spitting out a bunch of words to you that have the highest probability of being correct according to its weights and math calculations. So in a way, this is why ChatGPT can sound so convincing when it's giving you information that's completely and blatantly wrong, because according to its math calculations, it is 100% right. So this is why, specifically in the case of New Bing, there have been instances of it just straight up gaslighting people, because according to its math, it's 100% right and you're the wrong one. So yeah, neural networks are not perfect, but the problem with neural networks is if you make them perfect based on their training data, you're going to run into the issue known as overtraining, where this is a problem that neural networks face, where basically what happens is you overtrain, but to not use that word, essentially what happens is you get the neural network to be able to identify the training data so darn well that it can't generalize to be able to understand the broader concepts and data that isn't from the training data set. So one example that I have for you here is, pretend like we're going back to that person example, right? We're trying to identify people and images. So if your training data set, for example, which I guess this is a little different in its own right, but the fact that you need to have good training data in the sense is another aspect of training these neural networks. But let's say hypothetically you only were training it on, say, images of bodybuilders at competitions, right? So it might identify characteristics such as large muscles and shiny, oily skin as characteristics of a person, when that obviously does not translate to the average person. Since, God forbid, there's a person in an image that has clothes on, ooh, the AI is going to have no idea that that's a person, be like, nope, not a person. But that's because the data it's trained on wasn't an accurate representation. But more specifically, even if you did have a very broad and diverse selection of images to train on, if you train it too much, you get to the point where it'll fixate specifically on characteristics of that training data, where even if you have a diverse selection, there are some intricacies in that training data that it would narrow and focus in on and would lose some of its able to generalize. So that's one thing that you definitely have to be careful of. Now, we've been talking about trying to identify images. So we've kind of given the high-level overview of how it works. But for those of you who want to go a little more into the weeds here, basically, if we go back to, again, taking the example of trying to identify people, basically how it works is you take the image and you put it in through the input layer. Now, at the end of the day, how all this works is an image is literally just numbers, because essentially how it works is each pixel has a number associated with it for its RGB value, so it knows what color pixel to display. Now based off of that, what happens is there's this filter grid usually when you're dealing with images, you're using a convolutional neural network. So basically how that works is it'll go over it with like a filter grid. And then what this filter grid does is it multiplies the values with the filter grid against the image, and then basically maps that to a new matrix that can then be pooled and broken down further and further. And based on that pooling and breaking down further and further, that's how you identify characteristics in the image. So if in reality, the computer isn't actually seeing a person there, it's seeing number values that, based on the weights from its math equations, tell it that, oh, these number values are characteristics of a person, so this increases my likelihood to say that, yes, there is a person in the image. So to specifically go into how it works, the grid, it moves across the image multiple times to generate these numbers. So the filter is multiplied by the values in the image. As we mentioned, images are literally just numbers. So it's able to multiply that and create a feature map, which ends up being a larger big matrix. And then, as I mentioned, there's a lot of calculus and matrix math involved here. So that's kind of where the matrix math comes into play. And then the matrices are divided up into pooling layers, which are other layers in the neural network. And then there's a couple different ways you can do pooling. You can do max pooling, which is essentially you take the largest number in a subset of the matrix and you have that as your pooling layer for the smaller section. Or you can do average pooling, which kind of as it sounds, you take the average number of the subset of numbers in the matrix and create the new pooling layer. And the point of the pooling layer is just to reduce the image size down and reduce the number of input parameters. And this is how you get to identify characteristics in the image. And then based on this, you can adjust the weights accordingly to better to be able to identify various characteristics. And Bob's your uncle. You have a machine learning model that can identify people and images. So that's basically kind of a little bit more in the weeds. I'm not going into all of the math equations because, quite honestly, I haven't looked at them much at all because they kind of go over my head because there is a lot of math. It's very in-depth, and I would like to not put everyone to sleep. So we're not going to cover that. But if you want to, I mean, there's plenty of resources out there that you can look into how these various neural networks work. But at the end of the day, really what it boils down to is it takes in input data, does some fancy math, and then outputs a probability. And that's pretty much it. In the sense of, now when it comes to the difference, I guess you could say, with like these language models like ChatGPT that outputs words, essentially it would have like a dictionary of potential words, and then the probability it outputs is the probability of a specific word being the best choice for the given context. So if it's going through its calculations, it could have, say, like a 2% probability for the word the, 3% probability for the word blue, and then maybe a 95% probability for the word ice. So it would output ice as the next word in the string. And then similar for the ones that actually generate images, it's probably a similar thing where they would, take in the text prompt and then based off the training data it was trained on, would essentially create probabilities. Instead of, creating a probability for a given word, it would instead create probabilities for, different pixels being a certain color to then, generate the output image. But at the end of the day, if you ask anyone that's done machine learning, they don't know how the thing works on the inside, because they don't know how it works. I don't know how it works. I don't think anyone really know how it works. But at the end of the day, does anyone really know how the brain works? I mean, psychology is a field, and there's been a lot of, I guess, I don't know what the word is. There's a lot that has been understood, but there's also a lot of stuff that hasn't been understood, right? And it's the same thing with neural networks. Like, we know how to create the neural networks and to adjust the weights for the neural networks, but how all the stuff that goes on in the middle behind the scenes, it's kind of a mystery. And even people in the machine learning and deep learning areas will even admit that it's kind of a mystery. So that was a lot to digest. So at the end of the day, while ChatGPT is an AI, as well as my dinky little rock, paper, scissors program, there's a lot more to it than that. And I hope the one thing that you take away from this is the fact that AI is a very, very broad term, and it goes a lot deeper than, just the term AI. A lot of the things that you hear about today with AI is really this deep learning and machine learning stuff. It's not the high level AI because, like we mentioned, you can write any kind of program that has hard-coded any kind of intelligence, and that's technically considered AI. So, with that in mind, if you wanted to really impress people, what you could do is you could tell them that you wrote your own AI. So, for example, you could write a program, like we mentioned that kind of what number I'm thinking of game. Like, technically speaking, if you wrote a program that would start at whatever the lower bound was and just count upwards, that's an AI. I mean, granted, it's pretty terrible, but it's technically an AI because literally a computer is just a hunk of rocks with electricity shooting through it. So it can't guess what a number is. It has no idea what you mean. So if you can, have the computer count up and eventually get the number, that's some form of intelligence. Granted, not much, but it's some. You could also have it just randomly guess numbers. I mean, that also works too. Now, obviously, objectively, the better solution would be to implement a binary search into your methodology, because that would actually make the computer look pretty darn smart. And let's give a quick example here. So let's assume the range that you gave the computer for the number you're thinking of. Say you told the computer, I'm thinking of a number between 1 and 100. So whereas the incremental solution would start at 1, and then you'd say, nope, it's higher than that. And then it goes, is it 2? And they're like, no, it's higher than that. And then it goes 3, and then, it continues. How the binary search solution would work was it would say, is your number 50? And you're like, no, it's higher than that. And it'd be like, okay, is it 75? And you're like, no, it's higher than that. And be like, okay, is it 87? And then it narrows in. And basically how it works is binary, or 2. It essentially cuts the search space in half each time. So if we look at this at a high level, the searching, or the guessing incrementally 1 through whatever the range is, or whatever the lowest number of the range to the highest number of the range is, that would essentially have what we say in the software world as a big O of n, which essentially means it'll take n time as a worst case scenario to get the guess correctly. So if you have 100 elements, it'll take at worst 100 guesses to get the correct answer. Now, the binary search, on the other hand, has a big O of log n, specifically log base 2 of n. So what that means in normal people speak is if we have the same 100 elements, rather than taking a worst case scenario of 100 guesses, it would take log base 2n guesses, which if 100 is what our n is, it would take basically 5 guesses. So we take 100 guesses, and now we've shrunken that down to 5 guesses as a worst case scenario. Now, I don't know about you, but that's probably better than some humans would be able to guess if they don't know the underlying best case scenario of how to guess what the number someone's thinking of is. So that is definitely a pretty good, at least in my opinion, example of artificial intelligence, and a pretty good artificial intelligence that can pretty accurately and pretty quickly guess what number you're thinking of. And it actually looks smart because you can actually see it as it's going through, honing in on that number that you're thinking of, and hit it in a pretty short amount of time. Now, the reason why this is really, really good is because how scalable it is. Because how slowly log n grows. If you have, say, 1,000,000 elements, right? Your first guess, you immediately cut that 1,000,000 in half. And then you cut that 500,000 in half again, and then you cut that 250,000 in half again, and you keep cutting it in half each time, because you know that if I guess, say, 500,000 and your number is less than 500,000, I know I can just get rid of everything above 500,000 because you told me it's less. So you can immediately cut down your search space. Whereas if you started at 1 and just incremented up, I mean, good luck. So, yeah. So, I mean, but that's some artificial intelligence for you. So, and honestly, that's not a hard program to implement. Like, I kid you not, today, the day I'm recording this podcast, I wrote a program that does that in literally less than an hour. So it's pretty quick and easy to make an artificial intelligence, in all honesty. So go tell your friends and all your family members that you wrote an artificial intelligence, and they'll probably think that you're the smartest person in the world, even though literally all your thing can do is guess what number you're thinking of. Or, as even the most basic case, my first example of creating an artificial intelligence literally can just beat you at rock, paper, scissors without making it look obvious. So, that is the great world of artificial intelligence. Definitely, I guess you could say, just scratching the surface, since, as I mentioned, if you really want to get into the weeds, all the math behind it, there is a lot more to it. But I just wanted to get into that, make sure all of you are aware that when people are talking about artificial intelligence out in the public sphere, they're really talking about something deeper than that, and you can exploit that, because we love talking about exploits and cybersecurity principles here. You can exploit that limited knowledge that the public has to make yourself seem smarter than you actually are, because you can write a very simple artificial intelligence, because how broad the term artificial intelligence really is. Now, I think I've rambled long enough. Let's get back to this week's trivia question. So, to refresh your memory, this week's trivia question is, when was hyperthreading first introduced? So, if you said 2002, you are correct. And if you said it was introduced by Intel with their Xeon line, you get a bonus point. And then if you say it was also introduced later in 2002 with the Pentium 4, you get a third bonus point. So I hope some of you got that question right. I know we have talked about multi-threading before on the podcast. I don't remember specifically I've mentioned the date of when it was created. But, maybe some of you got that right. Hopefully you did. And I hope that you enjoyed this episode. And if you did, I ask that you leave it a rating and review, and subscribe to the Dark Assassins podcast if you haven't done so already. And also, definitely be sure to share this one with a friend or family member who's interested learning about going and actually understanding what artificial intelligence means, and how it's not only doesn't only apply to these super advanced models like ChatGPT and Stable Diffusion and the like. Now, if you have any questions about this episode, since I know we covered a lot, so if you have any questions about this episode, or have any questions for future episodes that you want me to cover, be sure to shoot me an email at contact@darkassassinsinc.com. There's a link for that down in the show notes. Love to hear your guys' questions. Love answering them. So feel free to hit me up there if you have any questions. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.